Today we're looking at modeling quadratic relationships. This is all about story problems and using quadratics to solve story problems that involve a parabola. Some of the hints that we want to look at when we're solving these story problems is one of the best things that you can do is sketch a picture. So a picture helps just you to visualize what's happening, and you need to know that most of these that we will be doing are in the shape of a parabola. Okay, so a parabola, it has that kind of that arc shape, and it could be going down or it could be going up. If it's going down, that's called concave down. And we're looking at that A value. When A is negative, it makes a frowny face. And when A is a positive number, it makes a happy face, okay? So the A value comes into play with whether it's concave down or concave up. So look at that picture and you'll know whether it's going up or down. We're trying to look, the next thing is you want to look, what are you looking for? Okay, so what is the problem asking for? If the problem is asking for a maximum or a minimum value, that's the high or lowest point. So the vertex is the highest point or the lowest point. Then you will need to find the vertex, okay? Then you need to look and see if you need an X or Y coordinate of the vertex or both, okay? So sometimes you'll just need the X coordinate of the vertex. Sometimes you'll just need the Y coordinate of the vertex. And sometimes you'll need an ordered pair of the entire vertex. The other thing that it could ask you for is you could have, with the parabolas, it could ask you for your zeros. So if you were kicking a ball and it came, like you were kicking it and you were wanting to find the two places where it hit the ground, those would be the zeros. So the next thing is determine what form the equation is in. So we want to see if it's in standard form, vertex form, or intercept form. And then we are going to look at domain and range in the context of this problem. Okay, so we also want to look at units in our answer. Okay, so here is an example. The height in feet of a projectile launched vertically upward off of a 120-foot tall building. So I'm going to draw just a rough picture of a 120-foot tall building. I'm going to write 120 feet. I'm going to, off of this building, we are going to be launching a projectile. Okay, so where T is time in seconds. So we have the y-axis and the x-axis. The y-axis is the height. The x-axis is the time, how long it is taking, how long it's moving. So it's giving us this formula. H equals 120 plus 16t minus 16t squared. Okay, so we have this height coming down. After how many seconds does the projectile reach its maximum height? Okay, so the maximum height would be right at the vertex. The vertex of this equation can be found when we know what form this equation is in. If I have 120 plus 16t minus 16t squared, I can rewrite that as negative 16t squared plus 16t plus 120, and this would be in standard form. Remember, standard form is where we write the highest power, then the next highest power, and then the number at the end is by itself. So when we're finding the vertex, this is in standard form. Okay, and when we find standard form, the vertex, we're going to take negative b over 2a, will give us our axis of symmetry, and the x is going to be right on the axis of symmetry. So we're going to start by finding x equals negative b over 2a. Well, we need to know what is a, b, and c. Okay, so looking here, our a is going to be the number with the t squared. So a equals negative 16, b equals positive 16, and c equals 120. So when we're finding our negative b over 2a, our b is 16, so we have negative 16 over 2 times a, which is negative 16. And we get negative 16 divided by negative 32, which equals 1/2. Okay, so we have 1/2 would be our x vertex. So this is saying that it is taking 1/2 a second for it to hit the maximum height. So how many seconds does the projectile reach its maximum height? That would be 1/2 second. Half a second. We want to find what the maximum height is. To find the maximum height, we take the 1/2 and we plug it in to the equation. So I have 120 plus 16t minus 16t squared, and that will give me the height. So I'm going to take 120 plus 16 times 1/2 minus 16 times 1/2 squared. This gives me 120 plus 8 minus 16, a half squared is 1/4. We have 120 plus 8 is 128. Minus 1/4 of 16 is 4, which gives me 124. Now this height is 124. I need to look at what the units are. So the units are in feet. So this is 124 feet high would be the highest that this projectile would go. So we have the vertex is 100 or 1/2 and 124 seconds. It takes 1/2 a second to get 124 feet tall. Okay, the next one, a football field with synthetic turf appear to be flat, but they actually have a parabolic cross section. So if you take a football field, there is a turf on top that's in the shape of a parabola. And this allows the rain to be run off the sides. This parabolic shape can be modeled by this equation, y equals negative 0.0002x times x minus 180, where x is the horizontal distance in feet and y is the height in feet. So this would be the y, and this would be our x. X is how far it is. So we want to see how wide is the field. If I made my axes here, and I started here, we want to find out how long this is. So we want to find our zeros to find how wide that field is. So I want to see when our y is 0, that height is 0, I have negative 0.0002x times x minus 180. So remember with our zero product property, we have two pieces. We have this negative 0.0002x. we also have the x minus 180. Now, since we have two things that are being multiplied, remember if I have parentheses here, that means multiplication. If I have two things being multiplied and they both equal 0, then negative 0.0002x equals 0, or x minus 180 equals 0. So we need to solve for what x is in both equations. If I take negative 0.0002 times x equals 0, then the x has to equal 0. Another way you could think about this is if I divide by negative 0.0002 on both sides, this cancels and leaves me x, and 0 divided by anything is 0. So x equals 0 here, or I can add 180 to both sides, and my x equals 180 feet. So if this is at 0 and this is 180 feet, we're looking at how wide that field is. It would be 180 feet wide. What is the maximum height of the field surface? So we are going to look at the how high does this go? Well, to find the vertex, we want to find where it's right in the middle here. So we are looking right in the middle is 90 feet. We want to see how high that gets at 90 feet. So to do that, we want to say y equals, we have our negative 0.002, but instead of putting an x, we're going to put 90. And then instead of the x on the second one, we put 90 minus 180. Okay, so I have 90 minus 180 is negative 90. So I have 90 times negative 90 times negative 0.00, I need another 0 there, 2. Okay, so we're going to put that right into the calculator. And that gives us 1.62 feet. Our next example is this Tacoma Narrows Bridge in Washington. It has two towers that are 307 feet above the roadway. It has a suspension cable, and each cable can be modeled by this function here. So x is the horizontal distance here, and the vertical distance is the feet above the road. So this right here would be our y, is the height above the road. Okay, so at its lowest point, how high is the road above the cable? So we are looking for the lowest point. It's a concave up parabola. So this piece right here is the vertex, okay? So we are looking for the vertex. Now we want to look at this equation. This right here is going to be in vertex form because we have the x minus 1400. So this is actually going to be really nice to find the vertex. We have 1 over 7,000 times x minus 1400 squared plus 27. Now remember, when we are finding the vertex, we want to take the opposite of what's in the parentheses, okay? Because parentheses you set equal to 0, that would give us positive 1400. And it would be up 27 feet off of the ground. So this distance here would be 1,400 feet, and the height would be 27 feet at the lowest point above the ground. Okay, now be careful this 1,400 feet is the vertex. So we are looking to find the distance between the two towers. So if it's the halfway mark is 1,400 feet, this side is 1,400 and this side is 1,400. All together, the distance between the two towers would be 2,800 feet. Okay, this last question says, there's a company and they sell digital cameras, and they have found that their revenue can be modeled by this equation. So revenue is how much money comes into a company. So this is a parabolic shape. It has a negative number here. Now, if you can think about this in terms of price, if you make your price really big, there is not a lot of people that will buy it, and you will have less sales because P is going to be the price of the camera. So this is our price. If we make our price really high, less people will buy it and we'll have less profit. If you make your price too low, then what happens is you'll sell a lot, but you're not making very much money because there's not enough money to be made if you're only making a few cents off a product. Right in the middle of this vertex would be the best price to put your camera. So we want to find which price is going to maximize that revenue. We want to get as much money coming into our company as possible. So if the equation is negative 5p squared plus 2560p, we are looking for the maximum revenue. Now this right here is in standard form. But we only have an A and a B, okay? We have A is negative 5 and B is 2560. So when we are finding our vertex, we're looking for the maximum amount. We are looking at negative B over 2A to put in for my X value. So if I take negative B, which is negative 2560, over 2 times A, which is negative 5, I have negative 2560 divided by negative 10. The negatives cancel to make a positive, and if I have 2,560 divided by 10, that equals $256. So the best price would be $256 for each camera, so that enough people will buy it, but we're making a profit on each camera. After we get that $256, we can plug it into the original equation to find what the revenue is. So if the equation is negative 5p squared plus 2560p, we're going to take that $256 and plug it into the equation. So we have negative 5 times our P, which is 256 squared plus 2,560 times 256. We're going to plug that into our calculator, and that gives us $327,680.